What does changing the slope of a line do to its graph? What changes? What stays the same? Let's take a look at a graphing calculator. Now, you don't have to know how to do all this stuff I just put in here, but basically this is going to graph a bunch of different slopes. We're using y equals mx plus b, and I'll hit zoom 6 graph. And then I'll talk, so there's 6 lines, and I'll talk to you about what's happening on each. Let's first look at these first 3. This line in the middle is y equals x plus 1. How does this line that's below it compare to it? How does the slope of this line compare to y equals x? And how does the slope of this line compare to this middle one? One thing that we can say about all 3 of them is they all have positive slopes. When we recall, slope is rise over run, change in vertical over change in horizontal. If the line is below, that means it doesn't have as much rise to it with the same run. So it's going to be flatter. If it's above it, it has a higher rise. And if it has a higher rise, then that number is going to be bigger. The line itself will be steeper. In these bottom 3, it's very similar to it, except these 3 are negative ones. And this is going to have a slope of -1. Now, we have to be careful when we're talking about negative numbers. So if we want to use that same idea, we have to talk about the absolute value of the numbers. So if the absolute value is less than it, it will be flatter, just like in this case. And if the absolute value is greater than, then it will be steeper, just like this one. Because negative, for example, if we don't look at the absolute value, -1/2 is actually greater than -1. So we look at the absolute value, and then we can just say, all right, 1/2 is smaller, so that will be not as flat, or it will be flatter, not as steep. So let's write some of this down. So what does changing the slope do? It changes the steepness of the line. If the slope is positive, the line goes up to the right. To the right. Now, some people want to talk about what's happening on the left, but when you're in math, we will go from left to right. So we'll talk about it goes up to the right, and then if the slope is negative, the line goes, oh, I didn't put in there, line goes up, it goes down to the right. The bigger the slope, and I'll just put in here parentheses absolute value when we're thinking about that, the steeper the graph. And the smaller the slope, again we're going to deal with that absolute value, the flatter the graph. And what stayed the same every single time? The y-intercept stayed the same. Now let's look at that next one. What does changing the y-intercept of a line do to its graph? What changes? What stays the same? Let's go back to the graphing calculator. And if I haven't said so thus far, you need to get a graphing calculator. We'll come over here, we'll turn this one off by not highlighting the equals. We highlight this one, and then I'll hit graph. So we have a bunch of different lines. What's staying the same and what changes? This time the y-intercept is changing and the slope stays the same. What did we talk about before about the slope staying the same? And we could see that in those graphs. They are parallel. So this time the y-intercept changes. The slope is the same, which makes all of the lines parallel. So what basically this y-intercept, we have this graph, and the graph is being shifted up and down. So remember, we have parallel lines. We have m1 equals m2. Perpendicular lines, we have m1 equals -1 over m2, or m1 times m2 equals -1. Let's apply that to a problem here. We have given L, which is y equals 3x plus 4, and a point A, 3, h, and B, 5, 10. Find h if the line segment AB is parallel to L. Well, one of the things I'm going to talk a lot about this year is somebody by the name of George Polya, who is considered the father of problem solving. Was a great mathematician, a Hungarian mathematician that taught extensively on just how to approach solving problems. When you see a problem, if you're not sure how to do it, you want to try to relate it. One way to do it is try to relate it to what you already know and then build on that. So when we look at this question and it says AB is parallel to L, well, what do we know about parallel lines? We just reviewed that. Their two slopes are the same. So now it becomes, can I find the slope of this line and can I find the slope of AB? Sure. Y equals mx plus b for the slope of the line, and we'll put m sub L is 3. And the slope of AB is, now we have the change in y over the change in x, and we did that the other day. We have y2 minus y1 over x2 minus x1. Now we can choose either point to be the x2, y2 point. I would prefer to keep the h positive, since that's our variable. So I'll put h minus 10 over 3 minus 5. Now what can we say about these two since they're parallel? That the slope of the line equals the slope of the segment. So 3 equals h minus 10 over -2. Multiply both sides by -2, so we get -6 equals h minus 10. Add 10, we get h equals 4. So the coordinates of that point would be 3, 4. The only thing it's asking us to do, though, is find h, so we're done. How does that change if AB is perpendicular to L? Well, we know on perpendicular ones we could either multiply them and get -1, or we could say that they're opposite reciprocal. Now it's your choice on which one you want to use. Most would tend to use this first one, which is fine. So the perpendicular slope, since the line has a slope of 3, the perpendicular slope would be opposite, negative, and reciprocal 1 over 3, since this 3 can be thought of as 3 over 1. Now we know that this is so A is perpendicular to this, so we're going to say the slope of AB, which we already found, h minus 10 over -2, is now going to equal -1/3. And multiply both sides by -2, So h minus 10 equals 2/3, add 10 to both sides, 10 and 2/3.